Good day everyone. Today, we'll explore the fascinating evolution of artificial intelligence, from symbolic systems to general intelligence. We'll unpack four core conceptions: artificial intelligence, machine learning, deep learning, and artificial general intelligence. Each represents a new step in machine intelligence, building on the last. This talk will provide you with a framework to understand how these concepts relate, and why they matter in our daily lives. Artificial intelligence, or AI, refers to machines performing human-like cognitive tasks, things like making decisions, solving problems, or navigating environments. The term was coined in 1956 by John McCarthy, and the earliest form of AI was called symbolic AI, also known as good old-fashioned AI. These systems followed explicit, rule-based logic to simulate reasoning. A classic example is Deep Blue, the chess engine that defeated Garry Kasparov in 1997. It didn't understand chess like a human, but it used carefully coded rules and massive search trees to evaluate millions of positions. Another example is GPS navigation. Symbolic AI helps it follow traffic rules and find routes using programmed decision trees. Similarly, industrial robots on assembly lines follow precise rule sets to complete tasks like welding or packaging. They don't learn, they execute predefined instructions. These systems are excellent at structured tasks, but they fall short in real-world ambiguity. They can't recognize a face, interpret sarcasm, or adapt to unexpected inputs. That limitation is what led to the rise of machine learning. Machine learning is a type of AI that learns from data instead of being manually programmed. Think of it like this: instead of writing rules for every situation, we feed the computer data and let it find the patterns on its own. There are three main types of machine learning. Supervised learning, where we train the system with labeled examples, like showing it emails marked spam or not spam. Unsupervised learning, where the system finds patterns in data without any labels, such as grouping customers by behavior. Reinforcement learning, where the system learns by trial and error, like getting rewarded for good predictions. You already use ML in daily life. Your spam filter learns to detect unwanted messages based on past examples. Netflix uses ML to suggest shows based on what you've watched. Credit risk models help banks decide who qualifies for a loan by learning from thousands of past applications. Machine learning is powerful because it lets machines improve with experience, just like humans. Deep learning is a type of machine learning that uses a special structure called a neural network, which is inspired by how our brain works. Think of a neural network like a chain of filters. Each layer processes the data a little more. For example, the first layer might detect edges in an image, the next might recognize shapes, and deeper layers could identify a face. The more layers, the deeper the learning. Deep learning is powerful because it can automatically discover important features from raw data, no manual coding needed. It's especially useful for big, complex tasks like image recognition, like detecting objects in photos; speech processing, like turning your voice into text; autonomous driving, where cars understand the road through cameras and sensors. Some examples you might know are Face ID on your phone, Siri or Google Assistant that respond to your voice, and medical imaging tools that help detect diseases from scans. Deep learning became famous after a model called AlexNet won an image recognition contest in 2012, cutting error rates nearly in half. That moment started the modern deep learning revolution. Artificial general intelligence, or AGI, is the idea of creating machines that have intelligence as broad and flexible as a human's. While current AI can do very specific tasks, like playing chess, recognizing faces, or driving cars, AGI would be able to do many different things, across many domains, just like people can. The goal of AGI is to build systems that can reason, learn, and improve themselves over time. In other words, an AGI system could learn a skill, apply it to a new problem, and even teach itself how to get better. Right now, AGI is still in the research stage, We haven't built one yet. But scientists are exploring ways to get there. These include cross-domain reasoning, letting machines combine knowledge from different areas, meta-learning, helping machines learn how to learn, self-improvement, enabling systems to upgrade themselves without human help. While tools like ChatGPT show some early signs of general abilities, but true AGI, a system that can learn and adapt like a human, is still a long-term goal. Let's take a quick journey through the major milestones in the evolution of artificial intelligence. 1950 Alan Turing introduces the idea of the Turing test, asking, can a machine's responses be indistinguishable from a human's? This was one of the first steps toward thinking about machine intelligence. 1956 The term artificial intelligence is officially coined at a conference at Dartmouth College, marking the formal birth of the field. 1980s we see the rise of expert systems like MYCIN, which used symbolic rules to help doctors diagnose infections. This era is often called the rule-based AI or symbolic AI phase. 1997 IBM's Deep Blue defeats chess world champion Garry Kasparov. It showed that machines could master complex games using brute force search and logical rules. 2012 A huge turning point. The deep learning model AlexNet wins a major image recognition competition. It used a deep neural network trained on GPUs and dramatically outperformed all previous systems. This marks the start of the deep learning revolution. Today, the focus has shifted to AGI research, building systems that can reason, learn, and adapt across different tasks, more like a human mind. While we're not there yet, it's the next big frontier in AI. Here's how it all connects. AI is the umbrella. It includes symbolic AI, the rule-based foundation; machine learning, pattern finding from data; AGI, the future goal. Deep learning is a subfield of ML. It's the most powerful and flexible form. Think of AI as a tree. Symbolic AI is one branch, ML is another, and DL is a branch of ML. In practice, many systems combine them. A self-driving car uses rules for traffic laws, ML to predict pedestrian behavior, and DL to process camera footage. Here's a side-by-side comparison of the four major approaches in AI. Symbolic AI doesn't learn from data. It follows strict rules, like a flowchart. It's great at logic and decision-making, but lacks flexibility. Machine learning uses data to find patterns. It's more adaptable than symbolic AI and works well on structured problems, like detecting spam or predicting loan defaults. Deep learning goes a step further. It uses neural networks with many layers to automatically learn features from complex data, like images, voice, or video. It requires more computing power but is excellent for perception-based tasks like Face ID. AGI research is focused on building machines that can generalize across tasks, just like a human would. It's still theoretical, and it demands extreme computing resources and new models of cognition. The overall trend is clear. We've moved from explicit programming to adaptive learning, from rule-based logic to intelligent systems that learn and improve. AGI represents the most ambitious goal, machines that could reason, learn, and adapt across domains, just like we do. Let's bring it all together. Symbolic AI follows human-written rules. Machine learning discovers patterns from data. Deep learning uses layered networks to make sense of complex information. AGI represents the future, machines that can truly understand, learn, and adapt across tasks. We've moved from simple, specialized systems to models that learn and evolve. The journey from symbolic AI to AGI isn't just technical, it's reshaping how we interact with technology, make decisions, and solve problems together. Thank you for joining me in exploring this evolution. I hope you now have a clearer view of where AI is today, and where it's headed. Well, finally, I'd be happy to answer any questions you may have.